Hi everyone. The logistic regression can be applied to classify the multi-class data by alternate approach directly predicting the probability of given input examples that belongs to each known class label. For example, if we have three classes with these samples, then directly it will classify the data uh, instead of using previous approaches one versus rest and one versus one. So here in the one versus rest and one versus one, which is avoiding other classes by splitting the problem into multiple binary problems, okay, binary classification problems. Then we will apply the standard logistic regression model to each binary class classification problem. So here we will get sub problems decision boundaries to classify the multi-class data. But here we will apply multinomial logistic regression alternate approach to that previous standard binomial logistic regression approach to classify the each known class directly instead of splitting into sub problems. Here that splitting is not applied to reduce the time complexity. So here we are applying the cross entropy loss to calculate the loss function that is given here. Then change the output from single probability value into one probability for each class label. So that means here what we have used, we will take each decision boundary here in one versus rest, it will take any one class, then remaining all samples will be assumed as another class. So instead of that, here it will take each label, single class label for each class. So this is class 1, this is class 2, this is class 3. Directly it is predicting the values, I mean classes, by assigning the single value to each class label. So here the change in the code, here multi underscore class you have to give the binomial, right? And solver can be anything, LBFGS or SAGA or SA Newton hyphen CF. In binary class classification, we have used the OVR in the place of multi underscore class, but now we have to use multinomial. Okay, in the multiple class classification, we have to use multinomial, and you can use any solver here. SAG, SAGA, LBFGS like that, but the liblinear cannot be used for multi-class classification because which is limited to one versus rest approach, which we have seen in the starting of this session. As per this approach, directly it is classifying the value classes by assigning the probability value to each class. Then we will apply the cross function, cost function, cross entropy cost function to calculate the error. If there is error available, we can apply the gradient descent to update the parameters. This is new theta value equal to old theta value minus learning rate alpha and partial differentiation of that error with respect to each theta values available in the given data set, that is having the g equal to theta 0 plus theta 1 x1 plus etc theta n xn. So all the parameters can be updated by using the gradient descent approach. Thanks for watching.